Good day, everyone. This is KP the Math G. We're dealing with 2024 free response question number 6. And I do believe, as many of these that I have already put up out of this, let's see, I think I've got 164 videos now. I believe it's going to make 165. If not, it's going to be 164. I'm thinking this is going to be 165 though. I have probably several of these, and you can probably find those on my YouTube videos. If you look through that, you can probably find several of those that look like this. Some of them will say evaluate, some of them just say set it up but do not evaluate, and that's all you want to do. You don't want to waste a lot of time trying to evaluate something. And besides that, you probably could evaluate this by hand, but you don't have to. It says set it up but do not evaluate, so just kind of keep those things in mind. All you're doing is just setting up the problems. We're doing parts A and I want to say part C. We've already done part B before. This is write an integral expression that gives the area of region R. Okay. By the way, if you hear something that sounds like a blow dryer, my wife is drying her hair. So yeah, it is a blow dryer. Okay. Hair dryer, whatever you want to call it. This is very rough sketched. I don't have all the nice technology that a lot of people have, and really nice problems here, but we're going to make do. I mean, I'm thankful to have a whiteboard and some markers and an eraser and my mind. So with that, we're going to make do with what we have. I wish I could do better for you guys, but this is the best I could do, and I'm just thankful that I'm able to do it at all. So but let's go ahead and deal with the problem. It says, let me move over where you can read this. Write an integral expression that gives the area of region R. Now look at this. This curve, okay, is F. Alright, F at X. It is X squared plus 2. This is probably 2 right here. Should be. And then this one here is X squared. This G at X below it is going to be X squared minus 2X. Now listen to me. This is just region R. You have two expressions. You have two, let me say expressions. We're having two equations here. Anytime you have two of these, and it says it gives the area, you're looking for an area of region R. It is always, and if you want to do an isovenable right there, fine, go right ahead and do that. But it's always this minus this. I don't care where it is on the graph, whether it's below it, above it, I don't care where it is. It's always the top minus the bottom. Don't wonder why. It just is. Okay, I could tell you why. You got this y, and then this is the, minus this y. It's always going to be minus regardless. And so all you're doing here then is making sure you put the correct one there. It's the area. You're not using pi. You're not looking for a volume of rotation. Okay, if you're finding a volume of rotation, that's always going to be pi r squared. So don't get that mixed up with just area. Area is just, all you're doing is the top one happens to be F, the bottom one happens to be G. If you label these from the start, all you got to do then is say, now, we have an interval from, this region is from 0 to 2. I can put an isolate interval all the way over here, all the way over to 2. Alright, no further than that is region R. So 0 to 2, don't forget that right there. Okay, and all you got to do, instead of writing out if you want to write it out, that's fine, but you don't have to. Make sure you do F first. In this case, it is F at x minus G at x. I put it in parentheses, and I don't think they're going to count off if you don't put the dx here, but that's really the area, So this is always like a kind of like a thickness here, well, whatever. But anyway, that's it right there. You got both of these inside this region, F minus G. Simple as that. That's all you have to do. No pi goes out here. That's if you're trying to find volume, pi r squared, because you're making a circular rotation. Okay? Alright, so that is all you do for area. That's it. Make sure you have this correct from 0 to 2. That's all you got to do. Now, again, if you want to write this out, you can. It's just 0 to 2. F is x squared plus 2 minus, I'd like to box it in, like that. X squared minus 2x. Now listen, if you do this way, do not bother to distribute that minus sign at all. Just let it be like that if you want to do that. But it's still F minus G. That's all you're doing. Either way, you'll get the points. That's all you have to do. Alright, that's part A. Alright, part C. Okay, now, part C. We are still writing an integral expression. We are just wanting to rotate. Okay. Now, let's see what it says. What we want to do is we're wanting to rotate this. Well, I don't know. We're just going to write a integral expression. What we want to do is we're going to rotate region S. Alright, about y equals 20. Now, let's see, I think we can do it here. I think I've got room. Now you introduce pi. Anytime you are rotating a region, let me just read that to you so you'll know. It does say that. Write but do not evaluate an integral expression that gives the volume of solid, of the solid. The solid is region S, and the volume is you're rotating it. Okay, that's what we're still doing, the volume of solid. Same thing when we say rotate. Okay. When generated, the volume of solid generated when region S is rotated about the horizontal line y equals 20. So what we're looking at is a horizontal line. Let me get a different color here. Y equals 20 right here, right there. Okay, now this is the region. We are not concerned about this portion here. It's just this region right here. We're no longer really concerned about region R and even where it goes. So I'm going to just erase that part. We're not even concerned about it at all. We're just looking at region S. Okay. This is the part right here. So what we're going to do is we're going to attempt to do an isomorphism right here. Let me erase this S. Erase some of these little region parts. Okay. All right. Bear with me as I do this. Okay. Now right here we're going to do this. All right. And I'll come out and right there. All right. Okay. All right. Right there. And come down right here. Now what you got to remember is any time you're doing something like this, understand when you rotate it around, which I don't, if I were to rotate this around like this, okay, you're going to leave this region here, you're going to leave a hole right here, okay? So this hole needs to be, or this hole right here, you leave a hole right there. So you have a big circle minus this hole, because you don't want the hole there in the first place, right? So it's always going to be something like this. It's going to be pi, and if we look at it, we're going to look at it from 2 to 5. Always remember what that's going from. And you're looking at big R squared minus little r squared, and then of course delta x. Okay, the thickness of that. Okay. Now, big R. Let's look at that. We'll erase this. How tall is this in all? You know the answer. Look where it's going from. 0 to how far up? 20. All right, there you go. Your big R is 20. So what you're going to simply do is square 20. 20 squared is 400. So just simply put that up there. 400. Well, let's start with 20 squared so we can get the idea. Okay, 20 squared. No function is involved in that. That's how tall that is, right? Now we want to, and I've got videos on this, we want to subtract off this part right here. I want to subtract off. I want to take away that hole. Subtract this hole. Okay? I want to subtract that hole. Well, it's still circular, so how tall is this? Well, let's ask this question. How tall is this? It comes up to this point that touches this curve, doesn't it? That's a y, all right? This is g at x right here. This height is g at x, which is x squared minus 2x. If you want to put that in there, that's fine. I'm just going to use g at x. This height here is g at x. This little height right here, from here to this, where it stops right here, that's g at x. This whole height is 20, right? This whole height we know is 20. So we're just going to put 20, and we're just going to go and that's the entire height, right? So if we can take away this g at x, this is the hole that we want to take away. We're taking it away right here. Okay, so we're not, we want to take the hole away. So this is 20 minus this. Okay, this is g at x. So this portion is 20 minus g at x. So right there, and usually that's the way it is, 20, and then minus here, right here, 20 minus g at x squared. Always remember to square it. And I don't have any room for a dx, but I'm just going to put it down there. And that's all you got to do. Don't write this out right here. And, don't do any more work on this. Okay? You don't have to. All you got to do is make sure you're going from 2 to 5. That's all that we're concerned about. We're not concerned about 0 to 2 anymore. That was from our last problem. This was actually problem C right here. Okay, that's what you're doing right there. Anytime you have that right there, you're looking at the hole. If you see a hole here, okay, which we do, an empty space, that's a hole. Okay, just understand that. And so it's the total thing squared, pi in front, from 2 to 5, 20 squared minus, well, this whole that we're subtracting is this whole thing minus this. If we take this away, that's what we're taking away, is the whole anyway. So it's 20. This is 20. This is g at x. This part right then is 20 minus g at x. So right here, this part is 20 minus, I just don't have room, do I? Okay, this part right here is 20 minus g at x. This whole thing right in here. Okay. If this whole thing were 20 and this part right here was 12, this would be 20 minus 12, wouldn't it? Which is 8. 8 plus 12 is 20, right? So if this part right here is 20 and this part right here is 12, then this part is 20 minus 12, which is 8. We don't know how tall this is, so we just have to say g at x. You know what I'm saying? Over how tall this is. We got to take that away so we can subtract off the whole. Alright? And that's what we're doing right here. It's always this. Got a hole, this right here, minus, and then 20 minus g at x. I'm really hoping that by looking at this visual here, that you understand the different parts here. Okay, the different parts. Okay, this height, and now what's this part right here? I see 3 things here. This, and that. That's what I see when I'm doing this. And if you can focus your attention on that and get where you understand this, you will do these with a lot more ease. Now, had this been rotated about the x-axis, would you have a hole? If this were rotated about the x-axis alone, would you have a hole here? No. It'd just simply be ever how far up this is. So if you didn't have a hole and you were just rotating it about the x-axis, or y equals 0, you would have, and I know I'm getting very sloppy here, but just to give you an idea, so you wouldn't, so this is kind of I'm kind of mimicking the curve here like this. I'm getting a mirror image of this. See, there is no hole here. All of this is solid. And that's what you're talking about here. This has a hole. This region, I don't see these little marks up here, do you? No, this is a hole then. Okay? So if you don't have a hole, and it's just about y equals 0, which is the x-axis. Okay, that's what I'm trying to show you. Then it would still be pi from 2 to 5. And this r, this height, there's no big R minus little r because you don't have a hole. It'd just be this little r here. That's all you're dealing with here. That is just simply g at x squared dx. And that's all you got to do. That is that right there. That's a difference there between those two there. Okay. Like I said, I hope that you understand this better now. On this part A, you have two. You're just going, and it's always, no matter what you're dealing with, this top one minus this bottom one. Okay, that's it. So, alright, anyway, that's KP to Matt G signing off. I trust this helps you. I hope so anyway. If you would like to, if you have not subscribed, please do so. I don't like to talk about how many subscribers I have. Really, in comparison to what other people have, I don't have that many, but I still have a few. But I'm not worried about my own glory here. I'm not trying to make money off of this. It's not about me making money, and I don't have a whole lot of money, but I'm not hurting either. It's just that I want you to understand this is all for you, not for me. But it does do good if you subscribe to it, if you'd like to. If you don't, that's okay. If you'd like to hit that like button, that's great. I always smile when I do that. If you don't want to do that, that's okay. If you want to make a comment, make a comment. If you don't, well, at the very least, I hope you get something off this basic little whiteboard that I have. I know that looks jumbled up, but that's the best I can do, and I believe you can see what I'm doing here. So, anyway, I appreciate you tuning in. Again, this is not at all about me, but it does keep my 65-year-old mind sharp, and my wife deals with me very patiently. We're getting ready to go out and do some things today. Got a few chores we got to do, a little shopping to do maybe, and maybe got to work out after being snowed in for so many days. I'm ready to go to the gym now and work out. Well, I do got to lose some weight, don't I? That's beside the point with you. KP the Matt G signing off. Ladies and gentlemen, have a great day.